Good afternoon, and as you can tell, I'm in a different room than I have been previously. For Chapter 1 and Chapter 2, I finally got connected up with IT, and they're letting me use one of their rooms and their video cameras. So hopefully, next week I'll actually have the chapters to you previously. So by Tuesday, you'll have a quick little lecture via YouTube, via the videos done. And I apologize for this week and not getting them to you sooner. But hopefully, as I've already received some assignments, the first two chapters were review, so you're able to handle that. But Chapter 2, we're going to cover fractions. And did you know that 5 out of 4 students have problems with fractions? And that's why we're going to take a look at them today. But what is a fraction? Basically, it is broken down. You can look at a pie, you can look at quite a few things, but it's just a numerator over a denominator. There are 3 types. You have your proper fractions, which are less than 1. You have your improper fractions that are greater than 1 or equal to. And then you have your mixed numbers, which is just your improper put in proper form and added with whole numbers in front. So one of the best ways to convert improper fraction to a whole number, or to a mixed number, as they're called, is to take a look. And so we're gonna look at this one right here. It's called 89 ninths is what we're gonna look at. And what we do is we actually turn it into a division problem. And so we're gonna take our 89 and actually divide it by our 9. So our numerator is gonna get divided by our denominator. And can 9 go into 8? No, but 9 can go into 89. How many times? 9 times, because I know 9 times 9 is 81. So I have my 89, and I have my 81, so I have a remainder of 8. And so we learned in the first chapter that we wanted to write remainder, or R, whatever the remainder was. This time we have a remainder of 8. Well, what does that go over? That actually goes over our denominator. So we actually then have 9 and 8 ninths. So that's kind of how that works. Now what if I wanted to go the reverse? So what if I wanted to go mixed numbers to improper fractions? Well, then it's simple again. We have our whole number and we have our denominator. And so I'm going to multiply my denominator by my whole number. So 8 times 8 is 64. And then I add what my remainder is. And that is my numerator. So 64 plus 7 is 71. So I have 71 eighths. So that's kind of how we add fractions, and that's the 3 types of fractions. When we get into fractions that aren't so nice, we need to be able to find, basically, as it's called, the greatest common divisor. We've got to be able to get to the lowest terms. We want to come down to the smallest fraction that we can get to. And how they explain it in the book is by dividing the numerator and the denominator to get the remainder, which we just worked through. And then you keep on doing that until you get a 0. So that way you know that you have the greatest lowest term that you can actually reduce it down to. When looking, you should look in your book, check out page 39. There's a green chart, and it talks about just numbers that divide well. So 2's, if you look at the evens, you got your 3 that goes to 3, 6, 9. You got your 5's, your 5 10's, 15's, your 25's. And it just kind of breaks it down. If you actually can add the number across, so 81, 8 plus 1 is 9. Well, you know that's divisible by 3. So there's some tricks that are talked about in the book. So you might want to be paying attention to what the book actually has to say. Now, one important thing is we're always not going to have the greatest common denominator, or the divisor, as it's said here. So we want to be able to raise or convert our fractions to higher terms, or higher fractions. And so one of the best ways to do that is by practicing it. So we have our number 4 sevenths. What is that raised to the 28th, to the blank over 28th? And this is going to be used for when we add or subtract. We want to get to the same common denominator. And so what's going to happen is I know that I look and I see that this denominator of 28 is divisible by 7. How many times? It's by 4. And so what I'm going to do is then multiply this number to get my denominators to be the same. So I'm going to go 4 times 7 is 28. 4 times 4 is 16. And that's why we have the answer of 16 28ths. And how did I know that? Well, I did 28 divided by 7 is 4, and I have no more remainders, and so I know that's going to be my greatest common divisor or denominator. Another way of looking at the addition and subtraction of fraction is trying to find the lowest common denominator, or it's called least common in the book as well. And there's two main methods. There's the inspection method, which is trial and error, and then there's the prime numbers method. And so let's work these problems out. Let's see if we can actually do what the book says to figure it out. So inspection. I'm going to look and I'm going to see that 21 divided by 7 is 3. Okay, and I have no remainders left. So I know I'm going to have to times this by 3 on the top, so my numerator, and 3 on the bottom to get them to the same. So now I have 9 21sts plus 5 21sts, and that gets 14 21sts. Now am I done? Almost. Now remember, I have to reduce down. What can I reduce down by? Well, both of these can take out a 7. So I actually have 2/3 left. Okay. Well, that's kind of easy, but it's done by inspection and trial and error. Is there another way we can do it? Well, let's look at prime numbers and the method that they use here. So here we have an equation, 1/3 plus 1/8 plus 1/9 plus 1/12 equals what? Okay. Well, let's figure it out by using how the book describes to use prime numbers. And what that means is we are going to look for something, and first off I should establish what is a prime number. A prime number is a number that's divisible by 1 and itself only. So basically after 2, the evens are out. So prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and so on and so forth. You know, because they're only divisible by themselves and 1. So I'm going to look here, and I'm going to try to find the least prime number that I can do division out of 2 numbers here. And let's start with the lowest. So 2 is my lowest. So I'm going to start with 2. Can 3 be divided by 2? No, so I'm just going to carry it down. Can 2 go into 8? Yes, 4 times. Can 2 go into 9? No. Can 2 go into 12? Yes, with 6. Okay, so since I had 2 numbers that could be divided by 2, I can use it. Now I'm going to go on to the next row. So I have my numbers remaining. Let's go 2 again, because I see that there's still 2 numbers that can still be divisible by my lowest prime. Can 2 go into 3? No. Can 2 go into 4? Yeah, and it gives me a 2. Can 2 go into 9? No. Can 2 go into 6? Yes, it can, and it gives me a 3. Okay, now I see I still have a 2. Can I carry on with that? Well, no, I need to actually go to the next prime. So 2's are done, so I'm going to go to the 3rd prime. So 3 is prime. Can 3 go into 3? Yeah, 1 time. Can 3 go into 2? No. Can 3 go into 9? Yes, 3 times. Can 3 go into 3? Yes, 1 time. So then what I do is I take my numbers, 2, 2, 3, and I multiply them all against the numbers that I have left. So 2 times 2 times 3 times 1 times 2 times 3 times 1 equals 72. Okay, am I done? Almost. So now I know that my lowest common denominator is 72. So now I have to put these all to the same denominator. So 1/3 of 72, because I like math, I can see that that's going to be 24 72ths. So I'm going to write that here. 24 72ths added to, well, if I know I'm trying to get to 72, 8 times 9 is 72. So 9 72ths plus reverse 8 72ths plus 6 72ths, because 6 times 12 is 72. And I add these together, so 6 and 24 is 30, plus 9 is 39, plus 8 gives me 47 72ths. And there, my friends, is the answer to that simple math equation. So we know how to add. How do we do subtraction, multiplication, and division? And I wrote some simple steps and then a couple problems to work out so you can get the gist of it. So subtraction, we want to find the lowest common denominator, which is what we just did. We want to get equivalent value. Then we want to subtract and place it back over the LCD. And then we want to reduce down. So let's try that with here. So we got 81 1/2 minus 56 78. So I need to get my 1/2 to a 7 or to an 8. So I'm going to go 4 8 because that's equal to my 1/2. Now, can I subtract 4 to 7? No, so I'm going to have to borrow. So I'm going to take out my 1, give it a 0, and I'm going to carry. And I got 8, so I got 8 over 8. So I've got 12 8s minus 7 8s gives me 5 8s left. Now let's continue on with math. Okay, 8 can't, so I got to carry it over. 10 minus 6 is 4. 7 minus 5 is 2. So I've got 24 and 5 8s. Can I reduce it down any farther? No, I'm at my 5 8s, so that's all I can do for right there. Alright, so multiplication. A couple quick hints on that is look to reduce before you multiply and then reduce again. So let's write that in. Let's reduce before we multiply to then reduce again. Because this looks kind of scary. 6 17ths times 5 18ths times 17 20s. Well, if we wanted to do that, we'd do 6 times 5 times 17, so 30 times 17. Well, it can get kind of scuzzy because it just can. But what if we reduce first? So 6 goes into 18. I've got a 3 left over. Well, 17 goes into 17. I got a 1, and I've got a 1. I've got a 1, and I've got a 3. Oh wait, 5 goes into 20 4 times. So I have 1 times 1 times 1 equals 1 over 1 times 3 times 4, 12. So what used to be a very scary equation is now a simple 1/12. The last thing that this chapter covers is division, and it's called the reciprocal. And what that is it means just that it's inverted the divisor. So that means we need to invert the second number. And so to do this, I've done the equation already. But let's say 7 8 is divided by 3 and a 1/10. So what's that mean? Well, first I got to get all to the improper form. So I've got 7 8 divided by 7 8 divided by 31/10. Okay, now when we do division, we invert it and then we multiply. So I'm going to invert this one right here, meaning I'm going to flip it upside down, which gives me 10 31sts, and then I'm going to do multiplication. But I see that I can actually reduce down, so I can get a 2 out of the 10, and I can get a 2 out of the 8. So I got 5 left, and I got 4 left. So I've got 7/4 times 5 31sts. Kind of makes for a mouthful. But 7 times 5 is 35. 4 times 31 is 124. So that recaps Chapter 2. I look forward to making Chapter 3 and helping you guys out if you have any questions. Thanks.